Thanks, everyone. So I'm Madlen, and first I would like to say thank you for having me today and being able to present online. And so I'm currently based in New South Wales with the Department of Primary Industries. And today I'll be presenting part of my PhD research that I've been doing at the University of Western Australia with Cyber Chem Centre and other industry partners. And today I want to specifically focus on how honeybees regulate their nutrition at the colony level. And during my research, I was interested in comparing a variety of different natural pollen sources to see how honeybees can regulate that nutrition and what effect that has on the next generation of bees. So the type of floral resources that I was looking at are two forest species which are endemic to Western Australia. So that is Jarrah and Mary, which would be very familiar to all of you. And I also looked at two agricultural crop floral resources, so canola and clover. And the interesting thing there is that, in fact, those two, canola and clover, are much more closer to honeybees in ways that honeybees have actually involved with those floral resources. So I wanted to see how they compare in terms of supporting colony health. And we can measure colony health in different ways. So that is, for example, through brood production, as we have been seeing in some of the other presentations. We can look at longevity and how long honeybees live on various food sources, but we can also look at body composition, and that's what I will be looking at today. So in terms of body composition, it is an indicator of what sort of nutrients honeybees have available to them for supporting the nutrition of the next generation. And I'll be quickly going over amino acids. So some of you might have heard me present on amino acids before, but then also have a look at some of the fatty acids and minerals, which are all important nutritional components for honeybees, of course. So just a quick reminder, what happens if we do have nutritional deficiencies or if honeybees have access to limited nutrition? So we know that it can result in a reduced body weight for honeybees, which then in return can affect the lifespan of bees. So honeybees have a shortened lifespan under those conditions, and that overall will affect colony productivity, especially if you're trying to, for example, build hives on various floral resources, as we commonly do in Australia, and try to build colonies for crop pollination or for honey production. So that is just a little bit of background, and let's have a quick look also at larval nutrition and the nutrients that are important to bees. So specifically here, I'm focusing on pollen, because pollen is very important for brood production because it provides bees with most of their nutrients. So we're talking about proteins, which can be broken down into the amino acids, fats and the fatty acids, minerals, vitamins, and carbohydrates. And some of those nutrients we know much more about than others in terms of the requirement for honeybees, like, for example, proteins and the essential amino acids. But then what happens is that, so the nurse bees actually play such a crucial part in that, in the regulating the nutrients, because they are the ones that, in fact, not only feed the brood, but they feed all colony members at various times in managing the colony's nutrition. So the nurse bees need to develop their hypopharyngeal and mandibular glands in their head, which they specifically do in the first 5 to 6 days of their life, where they consume the largest amount of protein. And then they process that pollen and also the nectar they consume into jelly, which they then feed to the brood. So I was interested in how the nutritional composition of the food source translates through the nurse bees, through the food they provide to the larvae, into the emerging bees that are hatching and the next generation. So just quickly, how did I control the nutrition at the colony level in terms of experimental setup? So I prepared 40 colonies with 10 colonies each assigned to 4 different nutritional sources. So the colonies all had access to one of these for pollen and honey, then food up colonies from packages with sister queens, keep the genetics the same, and attached a pollen trap in front of the hives to really limit bees collecting any other pollen sources from the environment, and provided paddies to bees that are made up of pollen and honey of the assigned food sources. So the bees were restricted to their food source that I was interested in testing the effects on the body composition of the bees. So first, let's have a look at the amino acids. So another recap, amino acids are the building blocks of proteins, and they can be broken down into non-essential and essential amino acids. Now, the interesting thing is that for honeybees, we do know that they have 10 essential amino acids that they exclusively have to get from their diet, so they cannot use other amino acids, for example, as a precursor. And so I wanted to know what is the amino acid composition of those pollens? And just want to remind you here that we did, in the composition of the pollen, I did see quite a variability between the different amino acids, even though those pollen sources overall contained between 20 to 25% protein, which is generally classified as an average protein source for honeybees. And all I want you to take away from this graph is that there's variability in the essential amino acids for honeybees for those food sources. So when we then look at the minimum levels, I did find that one particular pollen source, and that is Jera, which is has also been found in other studies to be low in isoleucine, was not it was lower in Jera in that instance in the pollen, but when we then look at the composition in the bees, I was surprised and not at the same time, because I would expect bees to regulate their nutrition as much as possible, but it was still quite remarkable to what extent they controlled their nutritional needs, because as you can see in this graph here, the amino acid variability that we're seeing in the pollen is not evident in the bees anymore. So there was no difference in any of the essential amino acids between the body composition of the bees themselves, which in ways is excellent news, because it means that first, honeybees can obtain the nutrients from various different pollen sources, and they can also utilize it and then take the nutrition that they need to support their own health, which in this case, of course, is regulated through the nurse bees. So then also wanted to have a look at what happens with fatty acid. To what degree do honeybees regulate fatty acids, and what is the story in this case when they're feeding off those pollen sources? So fats, just like proteins, can be broken down into fatty acids. They can be classed into or grouped into different groups of fatty acids, and Clarissa explained that quite nicely in terms of polyunsaturated or unsaturated fatty acids having double bonds, in this case multiple double bonds or singular double bonds, and saturated fatty acids. So today I want to specifically focus on polyunsaturated fatty acids, because we know that in general for insects, they are known as the essential fatty acids. So they are fatty acids that in humans also fall under omega-3 and omega-6. We know that specifically omega-3 fatty acids are required in memory and learning ability in humans, and similar in honeybees, there has been found to be a link between memory and learning ability and having access to those essential fatty acids. So what are those essential fatty acids in honeybees? They are called linoleic and linolenic fatty acids. And in the this is a comparison to the food source compared to what I found in the bees. And very similar to the amino acids, you can see that there is some variability in linoleic and linolenic acid in the food source, but in honeybees, that seems to be fairly regulated and controlled again. So it really shows that honeybees do have that ability to regulate their nutrition very, very tightly. And just to emphasize here with the linolenic acid in Gera, it is present, but it is lower than the others. So it's just not very, very visible here on that particular scale. So then let's have a look at minerals. And some of you might already be guessing a little bit of a trend here. But minerals are quite interesting because they actually, in this case, in speaking of pollen, occur in quite a large range in terms of the amount of minerals that are present in the pollen. So we've got some, like, for example, potassium, phosphorus, sulfur, which are really quite abundant in pollen, and others like magnesium, zinc, and copper, which are present in much smaller quantities, even though those do vary between different pollen sources. So in this case, I'm comparing the paddies that the bees had access to pollen, and these are estimates that have been calculated by a review done by Black in 2006 on honeybee nutrition. They are estimates for minimum requirement of growth. So they provide a baseline to the best estimates we have at the moment in terms of what bees might need in terms of the mineral requirements from pollen. So they do not quite account for how much bees can actually access from the pollen, or if there's any minerals being excreted during consumption. So they're really a baseline as such for now. What I do want to show you is that yes, we do have that large difference between minerals and the different pollen sources, and in between minerals as well. And there's also something that Black highlights in his study is about sodium levels. So here we can see that sodium and manganese are actually lower compared to estimate amounts in pollen. But sodium is known to accumulate in body tissue in mammals, so it is likely that that is actually overestimated in this case as well. And for manganese, not quite sure, but in bees it also tends to level out. So in general, what I can say is that even though I saw all this variability in the pollens, when I again looked at the bees and the minerals we measured, there were no differences between the different treatments. However, I would still like to show you some examples of the spread that we are looking at. So let's have a look at some of those here. So for example, for calcium, you can see that in canola was specifically high in calcium levels, which here shows to be about even twice as high as Mary. In the bees, that was very controlled, and they again regulated that very tightly. Now, similar for magnesium values, again, canola was much higher in magnesium than any of the other pollen sources, and the bees again showed very similar levels of magnesium in the body tissue. Phosphorus was much higher in both agricultural crops compared to forest species, and the bees again regulated those minerals in their body tissues, or the nurse bees regulated that nutrition for the emerging bees. So what that really shows is that honeybees can, to a very large extent, tightly regulate their nutritional needs. And at the moment in the literature, there's also an emphasis on macronutrients. So for example, regulating the amount of protein compared to carbohydrate that bees are taking in as part of their diet rather than individual nutrients. But there's still a lot that we don't quite know yet about mineral requirements in fats and in minerals, for example, or vitamins as well. But what I do want to emphasize here is that, for one, we can see that honeybees can quite effectively rear and support the nutrition of the next generation based on different pollen sources, as long as they have access to those nutrients and to the extent where they can actually regulate it and obtain the nutrients to be able to support the next generation. But something I do want to quickly discuss as well is quality versus quantity, because even though if we assume that honeybees tightly regulate the nutrition to the highest degree they can to support the next generation, we still need to think about quantity as well, because we do know that the amount of pollen, for example, bees have access to will largely affect the growth of a colony overall. Plus, we know a few more things as well, and that is we see an effect on larvae. So if the quantity, even though we have the quality, the quantity of jelly in this case, if it is not available, we know that at the colony level, nurse bees and young adult bees will actually cannibalize larvae. There's also some evidence that shows that worker larvae might get kept off earlier if the nutrition is limited, which can result in lower body weight, which again can affect a shorter lifespan in honeybees. So there are still other factors that play a huge role in regulating nutrition at a colony level. And it also poses the question to what degree honeybees show differences in the composition, nutritional composition of the jelly as well, which we know, for example, in queen jelly, it is highly regulated for proteins, which was looked at across different countries where they found that there was more variation in fats and carbohydrates, for example. Less we know about worker jelly and in what range honeybees can operate to still support the nutrition if we look at pollen sources that are less supportive of the nutritional requirements than, for example, I've looked at here. The other question is also, what effects do we see on adult bees? So we know that adult bees or nurse bees can use up some of their own body stores to feed developing larvae, but what we don't know is what are their effects on their later adult life and their foraging ability. So there's still lots of questions to ask in that space and things to consider that surround this topic of how honeybees regulate their nutritional needs. So in summary, I think we can say that honeybees from this study can support their nutritional needs based on a variety of natural pollen sources, which poses the question that keepers could use other pollen sources than the pollen source they use to feed back to colonies. For example, during pollen shortage is berry pollen, so there is the potential to also use other pollen sources like jarrah, clover, and berry. And what are the effects of regulating nutrition at the colony on nurse bees? And we still need to consider quality versus quantity of jelly when we assess the overall nutritional quality of a hive. So with that, I would like to say thanks for listening, and also thank you to all my supervisors, collaborators, industry partners, friends and family that have supported me along the way. And if there are any questions, I will be happy to answer them.